Welcome back to the Beginner PLC Mega-Project. So far we have created our project, defined inputs and outputs, written simple ladder logic, and added latches and interlocks. Today we enter one of the most powerful tools in PLC programming, which is timers. Without timers, machines can control processes over time. You couldn't fill a bottle for exactly 5 seconds, or delay a motor start, or pulse a solenoid for a fraction of a second. Timers make all of that possible. In this episode, we will cover what timers are, three main Siemens timers, T-on, T-off, and TP. We talk about how they work inside the PLC, and then we will apply them to our project by programming the filling station of our packaging line. A timer is exactly what it sounds like. It measures time inside the PLC. Now, let's connect timers to the PLC scan cycle. Each scan, the PLC checks inputs, run logic, and update outputs. Timers are updated as part of this process. For example, if you program a T-on for 5 seconds, the PLC increments an internal counter every scan until it reaches 5, then turns on the done bit. That's why timers are accurate down to milliseconds, but their precision depends slightly on the scan cycle. Think about a press machine. You press the start button, the press closes and applies force, then holds for 5 seconds before opening again. That's essentially a PLC timer controlling the press operation. It keeps the output active for a set time, then automatically turns it off. In automation, timers are used to fill a bottle for a couple of seconds, delay a conveyor so another machine has time to finish, keep a motor running for a short time after input is removed, flash a lamp on and off, pulse a reject solenoid for half a second. So it's important to know different types of timers and how to program them inside the PLC. Siemens PLCs give us three main timers, and it's critical to understand the difference between them. The first timer is T-on or on-delay timer. In this timer, when the input goes on, the timer starts counting, and after the preset time, the output turns on. The second one is T-off or off-delay timer. In this timer, when the input goes off, the timer starts counting, and the output stays on until the time expires. The last timer that we discuss in this video is TP or pulse timer. In this one, when the input goes on, the output turns on for a set time and then turns off automatically. So to summarize, think of T-on as a delay before starting, T-off as a delay before stopping, and TP as a pulse generator. This is the PLC Beginner Mega-Project playlist. We're building a complete packaging line step by step, learning timers, counters, alarms, and HMI along the way. If you're enjoying the playlist, please support the channel by liking the video and subscribing. Your support really helps me create more content like this. So today we'll combine three different types of timers, T-on, TP, and T-off, to create a realistic filling cycle with three stages: waiting at the start, filling in the middle, and waiting at the end before the conveyor moves. Let's picture a real factory. Imagine a bottle of soda sliding along the conveyor. If we immediately open the valve the instant the sensor says it, chances are the bottle isn't perfectly aligned yet. And the result, of course, inconsistent filling. That's why we introduce a stabilization time. So the bottle arrives, it stops, it waits for a few seconds. Once it's steady, the filling valve opens for exact amount of time needed, and Even after that, the valve closes. We don't just push the bottle away instantly. We give it a clearing delay, a few seconds for the last drops to settle, for the nozzle to react, or for other safety checks. And so this sequence is what makes the process smooth, efficient, and reliable. Okay, now let's open TIA Portal and go to OB1 and let's continue programming our project. To start, we need to define a new tag, so go to the tag table, main IO. So here we have bottle sensor. That is actually the sensor that we are going to use in our project today. And we need to define a new one. We name it fill valve, and that is actually the output coil that opens and closes the solenoid valve to let the liquid flow. Awesome. The address can be Q0.3. Okay, so let me minimize my simulator and go back to OB1. Okay, I create a new network. So here we'll use a T-on or on-delay timer. Remember, T-on waits for a certain preset time before switching its output on. And so for that, I will go to the instruction and to the timers folder, timer operations, and pick a T-on timer. And we drag and drop it to our, you see it's on delay, so I drag and drop this timer in network 2. So here is asking about creating a data block. Actually, the timer saves its data in its own instance data block. You only need to assign a name and click on OK. So you have your data block on network 2. As you can see, you have two inputs, in and PT. In is actually the conditions that you want to start your timer, and PT is the preset time that you set for the timer. Okay, so here's the logic. As soon as the bottle presence sensor is activated, we start a T-on timer set to 3 seconds. So for that, I add a normally open contact and assign it to the bottle present tag. Beautiful. And set the preset time to 3 seconds. For that, there is a defined syntax, and that is T hashtag 3S, which is the seconds. So on the output side, for sure, we need to have a memory bit. We want after 3 seconds, the T-on output goes high, and this sets our memory bit, which we need to define that. So for that, let's go to the tags and let's create a new tag table, and let's name it internal memory. So here we add a new tag, we name it ready to fill, and the address can be M0.0. Doesn't really matter, you can choose whatever you want. Just remember, we don't want to have any conflicts in our memory assignments. So for output here, we assign ready to fill memory bits. So after 3 seconds, the T-on output goes high, and this sets our memory bit ready to fill. Think of this as the bottle pausing under the nozzle for 3 seconds, nothing happens, the valve is closed. Then, once the timer finishes, the system knows the bottle is ready. Now, for the actual filling stage, as soon as the ready to fill bit goes high, we want to open the valve for exactly 5 seconds. For that, we will use a TP timer, and as you know, TP stands for pulse timer. So we go back to the timer operations folder and drag and drop a TP and add it to network free. So here again asks about the data block. Here just remember, assign a different name and hit on OK. The beauty of TP is that it doesn't need us to switch it off. The moment it's triggered, it stays on for the preset time, and then it actually automatically turns off. So our logic is ready to fill as the input of this timer. So we added a new open contact and assign it to ready to fill. That starts the TP timer, and we set the preset time to 5 seconds. So again, same syntax. And the TP timer output energizes the fill valve, which we added to our tag table. And for those 5 seconds, liquid flows into the bottle. After exactly 5 seconds, the TP resets and the valve closes. This means every bottle gets the same consistent amount of liquid, no underfilling and no overfilling. Okay, before adding more blocks into our project, let's do a quick simulation here and see how our logic works so far. So I again open my simulator and add a new sim table. As I showed you previously, you can go to the tag tab and you can filter out your signals. So we can have only inputs, and I'm gonna add basically all of my inputs. I show up the outputs and will add my outputs on the screen. Okay, so here I save my project and switch to online mode and monitor the block. So on the simulator, you can force the bottle sensor signal to high, and then you can see that our T-on timer starts counting, and after 3 seconds, ready to fill goes high, and you can also see that TP starts and keeps the fill valve tags high for 5 seconds. Let's run the simulation again. I force the bottle present input on, and the bottle waits for 3 seconds. The ready to fill bit goes high, and after 3 seconds the valve opens and it stays open for 5 seconds and then goes off. Okay, so everything works perfectly. Let's continue adding the other blocks. Okay, the third stage is another waiting period. Once the valve closes, we don't want the conveyor to immediately move the bottle away. So here I add a TOF timer. And again, I assign a new data block. Again, remember to set a different name so there is no conflict. The idea is maybe a few drops are still falling. Maybe the nozzle needs to retract. This is where we use a TOF timer or off delay timer. So I add a new normally open contact. The idea is while the fill valve is energized, the TOF input is on. Assign the normally open contact to fill valve, and the preset time here is 3 seconds. So when the valve closes, TOF output stays on for an additional 3 seconds. For the output, we can create another internal tag. I name it filling and set it to M0.1. So with this internal tag, we can know that the filling process is ongoing, and it takes in total 8 seconds. So 5 seconds for the filling stage and 3 seconds for basically waiting after filling. That means the bottle is held in place even after the filling is finished, giving it time to stabilize. Once those 3 seconds pass, the station is ready to release the bottle and move on. Okay, to bring it all together, we will also use a total cycle timer. So here I create another network and I name it conveyor control because this time is important. That is actually the time that we need to stop the conveyor. For that, we're gonna need a TP. Again, this is a TP set to 11 seconds. That is actually the sum of all 3 stages. So I drag and drop it to network 5. Same procedure, a different name to the data block. And there we go. So the idea is as soon as the bottle present sensor is triggered, this TP starts. While the TP is on, the station is considered busy and the conveyor can be held stopped. Once the TP finishes, the cycle is complete and the conveyor can move again to bring the next bottle. This ensures that our conveyor and filling sequence are perfectly synchronized. So I'm gonna name our networks. So this one is pre-filling. This 5 second is actually the filling stage, and the network 4 is actually the post-filling stage. Okay, I set the preset time to 11 seconds, which is the sum of the 3 previous stages. And on the output side, I need to create a new memory bit. Let's name it conveyor stop. And save the project. Assign it to conveyor stop. Okay, so now we need to modify our conveyor control network. So here on the reset, I'm gonna add a new branch and a new normally open contact, and I assign it to conveyor stop memory bit, and I close the branch. Beautiful. So our logic is complete. I save the project and download to the simulator. Okay, I switch it to monitoring and nice. So let's run the simulation. Here we have all the inputs. For that, I will start the conveyor, and you can see the conveyor motor started, and you see the output code is high. So here, let's look at the timers. Let me make it a bit smaller, which we can see all the timers together. Okay, it's beautiful. I'll bring back the simulator. So here I force the bottle sensor, input on. The bottle waits for 3 seconds. The ready to fill bit goes high. After 3 seconds, the valve opens and it stays open for 5 seconds. At 8 seconds, the valve closes, but the bottle doesn't leave yet. The TOF holds it for another 3 seconds. And at 11 seconds, the entire cycle is finished and the conveyor can move the bottle away. So that's basically the sequence of filling the bottle. I'm gonna force it again, and you see how the sequence moves on. Awesome. And that's it. A complete filling sequence using T-on, TP, and T-off timers working together. This kind of sequence is everywhere in automation, in bottling plants, packaging machines, and even chemical dosing systems. If you like this video, give it a thumbs up and subscribe to follow the playlist, and see you in the next one.